Good morning, dear students. My name is Ferhan Mazher, and today is 25th January 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a theory paper. We have selected October-November 2021 2-2 paper. The section A of this paper we have already solved, and we have uploaded the video in my YouTube channel. Today we are going to attempt the section B of this paper. And the section B comprises of 3 questions and we will solve them. So let's start today's paper. This is Cambridge O Levels Physics 5054. So October, November 2021, 2-2 paper, section B of this paper. Today we are going to attempt question number 7. A hydraulic press is used at a recycling center to compress waste material. Figure 7.1 is a side view of the press. So let me reduce the size so you can see the thing. Okay. So this is the side view. So from here, the force is applied. Here we have the oil, and this oil, when comes here, it put pressure on this piston. This is piston number 2. This is piston number 1. So this piston will go downward, and when this piston will go downward, here we have the waste, and that waste will be compressed. Okay. A force to the left is exerted on the piston 1. Oil is pushed along the pipe, and this moves piston 2 downwards. Piston 2 compresses the waste. Oil is a liquid. The question is, oil is a liquid. State the property of a liquid that makes it suitable for use in a hydraulic press. The liquid which we use in the hydraulic press, the most important characteristic in that liquid should be that it should be incompressible. So the oil which we are using in this hydraulic press is incompressible. So let me show you my written answer. Okay, so this is oil should be incompressible, or the liquid should be incompressible. So that's the first question number 7, A, first part. Okay, now the next question. Question number 7A, second part. He says, explain in terms of molecules why a liquid has this property. So a liquid which is incompressible, why the liquid is incompressible? The reason is the molecules in the liquid, they are close to each other. And the most important thing is that the molecules of the liquid, they have a very strong repulsive force with each other. So when you try to bring them close, when you try to compress them, because they have very strong repulsive force with each other, so that's why the liquid cannot be compressed, because they have a very strong repulsive force with each other. Plus the liquid molecules are already very close to each other. So you cannot bring them further closer to each other. So let me show you my written answer. Okay, molecules of liquid are close to each other. They have very strong repulsive force with each other. So these are the 2 reasons. Okay, so the B part, question number 7, B part. Suggest one advantage of using oil as the liquid in a hydraulic press. Another advantage of using the oil is incompressible, and the other reason can be that the oil acts as a lubricant. So those pistons and that cylinder, there was a lubricated. Oil acts as a lubricant. It reduces the friction between the piston and the cylinder. So it acts as a lubricant. So it reduces friction. Let me show you my answer. This is question number 7, and it's B part. Oil acts as a lubricant and reduces friction between the piston and the cylinder. It's important to write between the piston and the cylinder. Okay, so let's go. Let's move to the next part. So question number C, question number 7, C part. The cross-sectional area of the piston 1 is 0.018 meters square. Piston 1 exerts a force of 4,500 Newton on the oil. Calculate the pressure of the oil due to this force. You know the pressure is force divided by area. The formula for the pressure, F divided by A. The F is 4,500 Newton and the area is 0.018. 0.018 meters square. So, F is equals to P is equals to F by A, 4,500 Newton divided by 0.018 meters square. So P will be equals to 2.5 expo 5 Newton per meter square. Newton per meter square is also called Pascal. So the pressure will be 2.5 expo 5 Pascal. So that was question number 7C, first part. This was a numerical. I hope you understand, a very simple and a straightforward numerical. It was of 2 marks. Okay, question number 7C, second part. The pressure of the atmosphere is 1 expo 5 Pascal. Calculate the total pressure of the oil in the pipe. So the atmosphere pressure is also acting on it, and plus the pressure due to the force you applied is also there. So add both the pressures, the pressure which you got in the first part plus this pressure, and you will get the total pressure. So let me show you. Okay, so the total pressure will be equals to the pressure number 1, which we just calculated, and add atmospheric pressure into it. So 2.5 expo 5 plus 1 expo 5, and you will get 3.5 expo 5 Pascal. So question number 7C, second part. Okay. So now their question is the area of the piston 2 that is in contact with the oil is 1.4 meters square. Initially, the upper surface of the piston is level with the point P. Calculate the pressure exerted on the piston 2 due to the pressure calculated in the first part. So let me show you that diagram. This piston was actually here. The piston was here. Initially, it was here. Okay. So according to the Pascal's principle, the pressure which is created here, same pressure will be acting here. So the area is given. Okay. The area of the second piston we know, and we know the total pressure acting on that piston. So very easily I can calculate how much force is being exerted on the piston number 2. So let me show you my solution. So the P2 will be equal to the pressure total pressure which we just calculated in the previous part. The pressure 2 will be the force acted on the piston number 2 divided by the area of the piston number 2. And we know already the total pressure acting there, 3.5 expo 5. The area of the piston number 2 is 1.4 meters square. So F2 will be equal to 1.4 multiply 3.5 expo 5 equals to, and you will get 4.9 expo 5 Newton. So the force exerted on the piston number 2 will be 4.9 expo 5 Newton. So question number 7, and it's D part. As piston 1 moves along the pipe, the pressure of the oil in the pipe at the point P remains constant. Piston 2 moves downward. The pressure of the oil at the upper surface of the piston 2 increases. Explain why the pressure at the upper surface of the piston 2 increases. Okay. Let me show you that diagram. So you see what is happening here. This piston is going downward. When this piston goes downward, the oil is coming from displaced oil is coming, and it's on top of that that piston number 2. So the pressure which is here, the total pressure that is acting on this piston, no doubt. Plus another thing is happening. You see the depth of the oil as it goes down, the depth of the oil above this piston number 2's upper surface is increasing. So the weight of the oil which is above the upper surface of the piston number 2 is increasing, or you can say because the depth of the oil is increasing, so the pressure of the oil itself is also increasing. The pressure caused by the oil column, that is also increasing because the depth of the oil above the piston number 2 is increasing. The weight of the oil, because more oil is coming on the top of that piston number 2, So more weight of the oil is acting. So that's why the pressure exerted on the piston number 2 is gradually increasing. Where is that question? The question was, explain why the pressure at the upper surface of the piston 2 increases. Hopefully you understand. Let me show you my written answer. So, as the piston 2 moves downward, the depth of the oil above it increases. Weight of the oil increases because above the piston number 2 as more liquid comes above it. As depth of oil increases above piston 2, due to the depth, pressure of the oil on the upper surface of the piston 2 also increases. A little difficult answer. Okay, so we are done with this question number 7, D part, D first portion. Now, the second part, the density of the oil is 900 kg per meter cube. The upper surface of the piston 2 is now 0.50 meters below the level of the pipe. Calculate the increase in the force exerted at the upper surface of the piston 2 by the oil. Gravitational field strength G is 10 Newton per kg. So I know the surface area of that piston, that is 0.14 meter square. And we will calculate that this depth of oil, 0.50 meter depth of oil, how much pressure it will create. And then by multiplying that pressure with the area, I will be able to tell you how much is the extra force which is now being exerted on the piston number 2. So let me show you my working. I hope you understand the strategy which I just told you. Okay, so the depth of the oil above the piston number 2 is 0.50, and the density of the oil is 900 kg per meter cube. The G value is 10, so I can calculate that depth of the oil will have how much pressure. So that will be rho GH. Rho means density, G means the gravitational field strength, and H means the depth of the liquid above that point. So it will be 900 multiplied 10 multiplied 0.50. That will give you 4,500 Pascal. So this extra pressure is now acting due to that the liquid column above the piston number 2. And I can calculate the force due to this pressure. The force will be equal to the pressure times area. So you will have 4,500 times 1.4. It will give you 6,300 Newton. So the new extra force acting on the piston number 2 is 6,300 Newton. There is air trapped in the plastic bags that contains the waste. The temperature of the air in the bags remain constant. Explain in terms of molecules why the pressure of the trapped air increases as it is compressed. You see the air which is inside the plastic bags, when you compress it, and the temperature is not changing. So when you compress that air, so what happens? The volume of the air inside decreases. So the pressure obviously will increase. The reason is when you compress the air, the number of molecules, the number of air molecules per unit volume increases. Remember this sentence. The number of air molecules per unit volume, I said length, sorry, per unit volume increases. So this increases the collision frequency of the air molecules with the airbag walls of the airbag. So that's why the pressure of the air inside the bags will increase. So that is of a 3-mark question. Question number 7, E parts, and the question 7 will be completed. Let me show you my written answer, and then we will check the marking scheme. Okay, as air is compressed, volume of trapped air decreases. Number of air molecules per unit volume increases. Collision frequency of air molecules with walls of plastic bags increases. So the pressure of the air inside the bags will increase. Very important, a very famous question. I have seen this question many, many times in papers. Okay, so my dear students, we are done with the question number 7 of the section B of the October-November 2021 2-2 paper. The marking scheme of the question number 7 is showing up on your screen. You can pause the video and take your time, read, check the answers, check my answers, check your answers, check your teacher's answers, compare them with the marking scheme. It is very, very important habit. This is question number 7. I hope that you have read this marking scheme for the question number 7 and you have checked my answers, your teacher's answers. You have compared them with this marking scheme. Let's go to the next question. Okay, so we are going to the next question. He says the turning effect of a force is measured by its moment. Figure 8.1 shows force F acting on an object at point P. The object is free to rotate about an axis at X that is perpendicular to the page. Write down an expression for the moment of F about the axis at X. Draw on the figure 8.1 to show what is meant by any other term used in your expression. You see, the moment the moment of a force is equals to the product of the force and the perpendicular distance between the pivot and the line of action of the force. Or in other words, you can see the moment of a force is equals to the product of force and the moment arm. Moment arm is the perpendicular distance between the line of action of the force and the pivot. So let me show you my answer. It's a 2-mark question, very important thing. Okay, so here we go. So here you have to draw, this is basically the perpendicular distance between the line of action of the force and the pivot. So this is the moment arm. This red line is the moment arm, perpendicular distance between the line of action of the force and the pivot. So moment is equals to force multiply perpendicular distance between pivot and line of action of the force. So this is our answer. Hopefully you understand. Okay, so we are going to the next question. B, question number 8, B, first part. He says, state the principle of moments. Principle of moments says that if a body is in equilibrium, the sum of the clockwise moments will be equals to the sum of the anti-clockwise moments. You have to write this definition word to word. Don't forget, never forget this definition. It's a very famous definition. Frequently come in Cambridge exams. For a body in equilibrium, the sum of clockwise moments is equal to the sum of the anti-clockwise moments acting on that body. So the resultant moment will be 0. Let me show you. It's a 2-mark question. For a body in equilibrium, sum of clockwise moments is equal to the sum of anti-clockwise moments. Hopefully you understand. Okay. So that was the question number 8B first part. Now question number 8B second part. He says describe an experiment to verify the principle of moments. Include a diagram to help the description. You remember in your book Physics Matters, because we are studying from the Physics Matters. In the topic where we have the moment, the turning effect of the force, we have that article. You can write that article. It's a 3-mark article. And you can write here where you verify the principle of moments. And the methodology is very simple. You see what you do, you take a scale and you put a pivot under the center of the scale. And then you take 2 known loads. The loads, you know how much is their weight. And you hang 1 load on the left side of the pivot and 1 load on the right side of the pivot. And then you move those loads by the method of hit and try. You move them in and you find some place by moving them to some position of the weights on the ruler, so that the ruler becomes in equilibrium. The ruler becomes balanced on the pivot. Once you have balanced the ruler on the pivot by those 2 weights hanging, what you do, you check what is the distance of the weight number 1 from the pivot, and you check what is the distance of the weight number 2 from the pivot, and you multiply the weight number 1 with this distance, which I call D1. You get the moment produced by that weight. You multiply the weight 2 with the distance, that is distance from the pivot, and you call it D2, and that will be, so you will get the moment produced by the weight number 2. You will observe that both of them will have the same answer. Then you can change the weights and take new known loads and do the same procedure. Every time you will observe that when the body is in equilibrium, the moment produced by the left weight and the right weight, they will be equal to each other. In technical words, you can say the moment, the clockwise moment and the anti-clockwise moment, they will be equal to each other whenever the body is in equilibrium. So, and that is the principle of moments. So it's a 3-mark question. Let me show you my answer. Okay. So I have tried to write this answer in a short way. I don't know, but hopefully you can write a better answer. They ask us to write to make a diagram also. So here you can see I have drawn this is a scale and this is a pivot, and this scale has been balanced on this pivot. There is a weight hanging W1 on the left side. A W2 weight is hanging on the right side. The distance between the pivot and the W1 is D1, and the distance between the pivot and the W2 is D2. So this is trying to produce an anti-clockwise turning effect, and this is trying to produce a clockwise moment. Both these, because this thing is in balance, this is in equilibrium, so both the moments will be equal to each other. So let's listen carefully. He says, place a pivot under a rule. Hang 2 known loads on both sides of rule about pivot. Move W1 and W2 until the rule is balanced. So we will move them forward, backward, forward, backward. This will be a hit and trial method. So wherever they balance. Okay. So move W1 and W2 until the rule is balanced. D1 is the distance between W1 and pivot. D2 is the distance between W2 and the pivot. Calculate the moment of the W1, that will be equal to W1 into D1. Moment of the W2 will be equal to W2 multiplied D2. So you will observe that both moments are equal to each other. Clockwise moment will be equal to the anti-clockwise moment. Repeat experiment with the different weights. Always you will get the same answer. When the thing is balanced, the clockwise moment and the anti-clockwise moment, they will be equal to each other. Hopefully you understand. All right. So that was the question number 8B and the second part. Yeah, it was second part. Now we are moving to another question. He says a worker carries a ladder on his shoulders. His shoulder act as a pivot. So his shoulder here is acting like a pivot. Figure 8.2 shows that the ladder is horizontal. It is horizontal, so it means it has been balanced. The ladder is wider at one end, that this end is wider. This end of the ladder is narrow. So the mass of the ladder is wider at one end than at the other end. The mass of the ladder is 8.0 kg. The gravitational field strength is 10 Newton per kg. The first question coming up on your screen is, he says, calculate the weight of the ladder. We know the mass of the ladder. We know the gravitational field strength, and the question is calculate the weight of the ladder. You know, W is equals to mg. W is equals to mg, the formula for the weight. So m is 8 kg and g is 10. So just multiply them, you got 80 Newton. So the weight of the ladder will be 80 Newton. Hopefully you understand. Now, the next question coming up is, it says, state what is meant by the center of the mass. It's a definition, 1-mark definition. Center of the mass. Center of the mass is a point in the body where all its mass appears to be concentrated. Or you can also define it according to the marking scheme. You can also define it. Center of the mass is a point in the body where all the weight of the body seems to be acting. Another definition of the center of the mass is it's the point in the body. If I apply force on that point, the body will move in a straight line without rotation. So there are so many definitions. Okay, so point where all the weight of body seems to act, or you can define it like this: center of mass is a point in a body. If force is applied on that point, body moves without rotation. Body moves without rotation. Okay, so that's the definition of center of the mass. Okay, so let's go to the next part. Is this that was let's see second part? Okay. He says the center of mass of the ladder is not halfway along its length. State what this shows about the ladder. If the center of mass is not in the center of the ladder, it means that the ladder is not of the uniform thickness. It means that the mass is not distributed uniformly throughout the length of the ladder. It means at some point the ladder has more mass and on the other side it has less mass. So let me show you my written answer. It was a 1-mark question. Okay, what does it say? Mass is not uniformly distributed along the length of the ladder. Mass is not uniformly distributed along the length of the ladder. That is the answer. So, okay, let's go to the next part. He says that, okay, now we are here. The center of mass of ladder is a horizontal distance of 0.90 meter from the worker's shoulder. So the center of the mass is 0.90 meter from the pivot. He says calculate the moment about the worker's shoulder of the weight of the ladder. You see, weight is a force and its distance, its line of action is 0.90 meter away from the pivot. So I can calculate the moment produced by this weight, and the method is very simple. Moment will be equal to the weight multiply its perpendicular distance from the pivot, which is 0.90 meter. Let me show you my work. I have done this. Okay, so here we go. Moment is equals to weight multiply distance. 80 Newton multiply 0.90 meter, you get 72 Newton meter. The moment will be 72 Newton meter. That's question number 8C, fourth part. Okay, so let's go to the next part. Okay. Okay, that's the last part. He says a bucket of weight 87 Newton is suspended from the ladder at a horizontal distance of 1.3 meter from the worker's shoulder. The worker keeps the ladder horizontal by exerting a vertical force at the point L. L is a horizontal distance of 0.54 meter from his shoulder. Determine the size and direction of the force exerted at the L. So basically we are talking about here. You see here the bucket, this is the pivot, and this bucket's weight we know, and we know its moment arm also from the shoulder, which is acting like a pivot. And here is the center of the mass. It is trying to produce a anti-clockwise turning effect. This is trying to produce a clockwise turning effect. Here, this person will apply force either in the upward direction or in the downward direction. We don't know that, but he will apply force here. It can be upward, it can be downward. We will see, we will calculate, and we will know what is the direction of that force. And it's 0.54 meter, and the center of mass is 0.90 meter away. The bucket is 1.3 meter away from the pivot. Okay, so suppose this bucket is producing an anti-clockwise turning effect. This weight of the ladder is producing a clockwise turning effect. And let's suppose that this boy is with this hand. He is trying to produce a force in the upward direction. Suppose that. So if he is trying to produce a force in the upward direction, so this force will have anti-clockwise turning effect. So that anti-clockwise turning effect here plus that anti-clockwise turning effect here will be equal to the clockwise turning effect produced by the weight of the ladder. So we have supposed that the force exerted here is in the upward direction. Automatically this direction will be corrected if we have supposed the wrong direction. You will see how this works. It's a very simple and a straightforward question. Okay. So you can see I have simplified that diagram here. That bucket is acting, whose weight is 87 newtons, and its moment arm is 1.3 meter. Here, that for suppose that force acting here by the hand of that labor is in the upward direction, and its distance from the pivot is 0.54 meter. Here, the weight of the ladder is acting, which is 18 newton, and its distance from the pivot is 0.90 meter. So this is trying to produce an anti-clockwise turning effect. This is trying to produce an anti-clockwise turning effect. But this force here is trying to produce clockwise turning effect. So some of the anti-clockwise turning effects will be equal to the sum of the clockwise turning effect. So you can see here 87 into 1.3 plus F into 0.54 is equals to 80 into 0.90. So it will be 113.1 plus 0.54 F equals to 72. So when this 113.1 will go on the other side, it will subtract. And here you can see I've subtracted it. Then this 0.54 will go and divide there. So you get F minus 76.1. So minus 76.1, what does this mean? So the force will be acted, the force acting here by the hand of the labor will be 76.1 Newton. But what the negative sign means? Negative means that the direction which we have supposed that was upward, the actual force is not in that direction. Negative means this. So the F will be in the downward direction. The F will be 76.1 Newton and its direction will be downward. This direction thing is little new thing and it's little tricky. I hope you understand. Okay, so we are done. Now we are coming to the question number 9. But before we go to the question number 9, let's have a look at the marking scheme of the question number 8. So my dear students, the marking scheme of the question number 8 is showing up on your screen. Pause the video and take your time. Watch this marking scheme. Read this marking scheme. Discuss this marking scheme. Compare the answers which you are receiving, which you are writing with the marking scheme. Okay. 76 Newton and okay, question number 8, C part, let me see. Okay, so our answers are right. So now we are moving to the question number 9, which is the last question of this paper, subsection B. The filament lamp is connected to a 240 volt alternating current AC main supply. Describe how the output of an AC supply differs from the output of a direct current DC supply. Sketch 2 voltage time graphs in the blank space to help you explanation. So it's a 3-mark question. We have to draw the voltage and time graphs for the AC supply and for the DC supply. And then we have to write down some difference between them. So let me show you my written answer. You know, if you have drawn the voltage here, you can see I have drawn the AC voltage. So it goes up, it goes down, it goes up, it goes up. We call this wave shape, we call it sinusoidal. We call this shape sinusoidal. Okay, remember this name, sinusoidal shape. This waveform is sinusoidal. And this is the DC current. The DC current remains like a horizontal line. Its gradient remains constant. Its gradient is 0. It's a horizontal line. Okay. Here, the AC current, you can see it becomes positive, then negative, positive, negative, positive, negative, positive, negative. So the direction of the AC current is changing. EMF is changing. Its direction is basically changing. Plus, its magnitude is also changing. Sometimes you see here, the magnitude becomes maximum, then the magnitude becomes 0, magnitude becomes maximum, magnitude becomes 0. So the magnitude and the direction of the alternating current continuously changes, whereas the magnitude and the direction of the DC current remains constant. The graph of the AC is for the AC current, that is a sinusoidal wave, and the graph for our DC current is a horizontal line. AC changes in direction and magnitude with time. DC remains constant in direction and magnitude. AC voltage time graph is sinusoidal wave. DC voltage time graph is a straight horizontal line. Hope you understand. That was the question number 9, A part. Okay. The lamp is rated at 60 watt and designed to be used with a 240 volt supply, voltage supply. Calculate the current in the lamp. We know the power, we know the voltage. You remember the electric power is formula is P equals to IV. Famous formula. P equals to IV. Power is equals to the product of the current and the voltage. We know the voltage, we know the power. I can calculate the current flowing through. It's very simple. P equals to IV. So you can see on your screen, P equals to IV, 60 equals to I multiplied 240. 240 will go to the other side, it will divide. So I is equals to 60 divided by 240. I will be equals to 0.25 ampere. 0.25 ampere. I hope you will remember this formula and you understand how this is done. He says, calculate the resistance of the lamp. I know the voltage drop across the lamp. I know the current flowing through the lamp. I can calculate the resistance of the lamp according to the Ohm's law. V equals to IR and R is equals to V divided by I. And we know the voltage and we know the current. So V is equals to IR, R is equals to V divided by I. So 240 volt divided by 0.25 ampere. So you will get 960 ohm. So the resistance of that lamp is 960 ohm. A room is lit by 5 of these filament lamps connected in parallel. State 2 advantages of connecting the lamps in parallel rather than in series. You see, when you connect the 5 lamps parallel to each other, each of them will be receiving the same voltage. And they all will be lit at the same brightness. And if any one of them got fused or blown, the remaining will keep working. That is the advantage of putting them, connected them in parallel to each other. So let me show you my written answer also. So here we go. They all lit brightly. If anyone blows, the other lamps keep working. These are the 2 advantages. Okay. So here we go. The 5 lamps in the B third part are lit for an average time of 5.5 hours a day for a year. Electricity cost 0.15 kilowatt hour. Calculate the cost of using these lamps for a year. You see, back we can calculate the cost, and the method is you find the electric energy. The formula is power multiplied time, and then you multiply that electric energy with the cost, okay, of 1 kilowatt hour. But because we want the electric energy to be in the kilowatt hours, so the power should be taken in the kilowatts and the time should be taken in hours. So let me show you. There are 5 lamps. Okay. So here we go. So the cost will be power multiply time multiply price of the 1 unit, 1 kilowatt hour. So the power is 60 watts. So divide it with 1000. So it can be converted into kilowatts and then multiplied with the 5 because there are 5 lamps. The time is 5.5 hours a day, and there are 365 days in a year. So 5.5 multiplied 365 and multiply 0.15. That's the cost of 1 kilowatt hour electric energy. When you do them, when you enter them in your calculator, you will get $90.34. So your bill will be $90.34. Hopefully you understand this question. A student takes the lamp in the B to school and connects it to a circuit using a 1.5 volt cell, an ammeter and a voltmeter. The circuit is used to determine the resistance of the lamp. In the blank space, draw the circuit diagram of the circuit used to determine the resistance of the lamp. It's a very, very, very famous question. You have to draw the circuit so that you can find the resistance of a lamp or a resistance of a wire or a resistance of a fixed resistor. So what you do, you take an ammeter, you connect the ammeter in series with the lamp, you connect a voltmeter parallel to the lamp, and you attach them with the battery, and you note down what is the reading on the ammeter, what is the reading on the voltmeter. You divide the voltmeter reading with the ammeter reading, and that gives you the resistance of that lamp. So let me show you. That's a 2 marks question. Here we go. So you can see here I have drawn a diagram. Here we have a cell. It's a 1.5 volt cell. Here we have a switch. Here I have connected an ammeter. Ammeter is connected in series with the lamp. And here we have a voltmeter, which is connected parallel to the lamp. And here you go. So if you will close it, you will note down what is the reading on the ammeter. You will note down what is the reading on the voltmeter. You divide the voltmeter reading with the ammeter reading, and that will give you the resistance of this lamp. So this is that circuit which you have to draw. It's a 2 mark question. He says the value of the resistance of the filament lamp in this circuit differs greatly from the value calculated in the B second part. State how the resistance value in this circuit differs and explain why it differs. You see in the B second part, you connected that lamp with a 240, I think 240 volt. You connected it with a 240 volt supply, 240 volts. But this time you are connecting that lamp with 1.5 volt cell. So you see the voltage which you are connecting, the lamp is connected with a very low voltage, very, very low voltage. So the lamp will be very dim. So the lamp will be dim, and that's why the temperature of the lamp will be not high. The lamp will be cooler as compared to the B second part situation when you connected the lamp with a 240 volt supply. So the lamp was very bright, so the temperature of the lamp will be higher. When the temperature is higher, its resistance is higher. But when you connect this lamp with a 1.5 volt cell only, and the voltage will be low, the current will be low, the power loss, the power used by the lamp will be low. So the lamp filament will be not hot, so its resistance will be low as compared to the lamp where it was connected with the 240 voltage. It's a 2 mark question, and that's the last question of this this paper. Okay, so let me show you. Okay, so we are on the last part. It says low voltage and small amount of current. When you connect it with the 1.5 volt cell, the lamp will receive low voltage, only 1.5 volt, and a small amount of current. So lamp will be colder, so its resistance will be less. Here the lamp will be less bright, so it will not have that much temperature, so its resistance will be less. So that's it. So we are done with this paper. So let's have a look at the marking scheme. Okay, so my dear students, the marking scheme of the question number 9 is showing up on your screen. You can pause the video and you can take your time and read this marking carefully. I have already checked my answers with the marking scheme. So please take your time and read it carefully. This is the question number 9 marking scheme showing up on your screen. And I always told you that it's very important to check the marking scheme, to compare your answers with your marking scheme. So, my dear students, today we have done October, November 2021 Physics 5054-22 paper. This is theory paper. We call it paper 2. And today we have done the section B of this paper. Section A of this paper we have already done, and that video has been uploaded in my YouTube channel. And where you have found this video, in the same playlist, you will find that video above this. And so that's it for today. I hope that this video will be helpful to you. I believe I'm trying my best to explain all the concepts. So if you think that this video is helping you, this video is improving your answering skills, please subscribe my YouTube channel and also like this video. Share the link of this video with your friends, with your class fellows, especially with your junior students. So when they come in O levels final year and they start preparing, they already know from where to prepare. So thank you very much, everybody. It's a great pleasure for me to teach you online. So once again, thank you very much. Have a good day. God bless you all. Thank you very much.